Hello dear students, today we will learn a very interesting topic from current electricity. It is from class 12, Kirchhoff's laws. There are two laws of Kirchhoff's current law and Kirchhoff's voltage law. They are known as KCL and KVL. We will explain the theorem as well as we will do few numericals on the basis of that, and I hope after this video your concept will be crystal clear. So let's start. KCL, Kirchhoff's current law. So what is this statement? The algebraic sum of all the currents meeting at a junction point of any network is equal to the zero. That means we can write mathematically sum over I is equal to 0. The algebraic sum of all the currents is equal to 0. And we have to remember that KCL basically represent conservation of charge. It basically represents conservation of charge. Now we'll explain that thing. Let's say P is the junction point of a network. That point P is the junction point of a network. And I1 and I2 are the currents which are entering towards the point P. And I3 and I4 are the currents which are leaving from the point. So according to the notation, all the currents which are entering to the point P, they are taken as positive, and all the currents which are leaving from the point, they are taken as negative. So according to convention, so I1 plus I2 plus of minus I3 plus of minus I4 is equal to 0. Why I3 and I4 are negative? Just because they are leaving from the point P. So I1 plus I2 is equal to I3 plus I4. So you have to understand that thing. I1 plus I2 equal to I3 plus I4. That means total current that is entering to the point P must be equal to the amount of current that is leaving from the point P. Here I1 plus I2 is equal to I3 plus I4. That means total current that is entering to the point P is equal to the amount of total current that is leaving from the point P. Now we will solve few numericals on the basis of this. See these two problems. Here potential of that point is 20 volt and these 2 points are ground, and you have to find the potential of point P. So how you will calculate it? By applying KCL, we will be able to solve this problem very easily. Let the potential of that point is V. Let the potential of that point P is V. So now these 2 points are grounded. That means the potential of that point is 0 as well as the potential of that point is 0. So this end is higher potential. So let's say current is flowing in this direction, because we all know current always flows from higher potential to the lower potential. So let's say current is flowing through this direction, I current is flowing in this direction, and then it will divide into 2 parts. This is I1 and this is I2. So according to KCL, if you apply KCL at P, then the formula will be I equal to I1 plus I2, because at P, I is the current that is entering to the point P, and I1 and I2 are the currents which is leaving from the point P. Now according to formula, what is the value of current I? From Ohm's law, I is equal to 20 minus V divided by 5. Because V equal to IR, so I equal to V by R. That means potential difference divided by resistance. So potential of that point is 20 and potential of that point is V. We consider that the potential of that point is V. And I1 is basically V minus 0 by 10 plus V minus 0 by 2. This is 10 ohm and this is 2 ohm. So that will be 4 minus V by 5 is equal to V by 10 plus V by 2. So that will be V by 10 plus V by 2 plus V by 5. The LCM will be 10 and V plus 5V plus 2V, that will be the value because this is 5. So 40 equal to 8V. So V equal to 40 by 8, that means 5. So V equal to 5 volt. V equal to 5 volt. So the potential of that point is basically 5 volt. I believe everything is clear for all of you. For this problem, you have to find the value of resistance, and the potentials of these 2 points are given 7 volt and 4 volt. This is 3 ohm resistor, this is 4 ohm resistor, and the potential of that point is 20 volt, and the potential of that junction point is 10 volt. So here this end is higher potential. Let's say current will flows in this direction, just same as the previous one. So this is I, this is also I, and it will break in 2 parts. That was I1 and I2. Let this point is P. So by applying KCL at P, we can write I equal to I1 plus I2. So I will be 20 minus 10 divided by R. I1 will be 10 minus 7 by 3 plus 10 minus 4 by 4. This is the formula. So that will be 10 by R and that will be 3 by 3 plus 6 by 4. So this value will be 1 plus 3 by 2. That means 1 plus 1.5. That means 2.5. So the value is 10 by R equal to 2.5. So R will be 10 divided by 2.5. That means 4. So R equal to 4 ohm. So the value of this resistor is 4 ohm. See this circuit here, you have to find the value of I. So how we will solve it? By applying KCL, we can easily solve that one. Let this point is P, that one Q, that one R, and that is S. So if we apply KCL at P, then we can say that 15 ampere current is entering to the point P. So this is 15, and let's say this is I1 and this is I2. So we can write 15 equal to I1 plus I2 because I1 and I2 are the currents which are leaving from the point P. Now for S, at S, if you apply KCL, that will be 5 plus I2 and let's say that one is I3. So 5 plus I2 will be equal to I3. Why? Because I2 and 5 ampere, they are entering to the point S and I3 is leaving from the point S. Now we can say that the value of this current is I4. So if we apply KCL at Q, that will be I1 plus 3 is equal to I4. I1 plus 3 because I1 and 3 are entering to the point Q and I4 is leaving from the point Q. For R, if we apply KCL, that will be I3 plus I4 is equal to I. So our task is to find I. We have to find I3 plus I4. Let's say this is equation 1, this is 2, this is 3, and that one is equation 4. So from 1 and 2, we can write 15 is equal to I1 plus, instead of I2, we can write I3 minus 5. So that value will be 20 equal to I1 plus I3. And now we can also put the value of I1 from equation 3 in this equation. So that will be 20 equal to, we can write I1 equal to I4 minus 3 plus I3. So that will be 23 equal to I3 plus I4. And we know that I3 plus I4 is basically I. So we can say I equal to 23. So in this circuit, the value of current I is basically 23 ampere. Now we will learn KVL. What is KVL? Actually, Kirchhoff's voltage law. So according to KVL, the algebraic sum of all the voltages of a closed loop of any network is always equal to be 0. That is, sum of V equal to 0. Sum of all the potentials is equal to 0. And we have to remember, KVL basically represents conservation of energy. Now we have to apply this KVL to solve numericals. So before applying KVL, we must know that KVL is valid only for closed loop. This is valid only for closed circuits. Before solving, we should know what are the rules of applying KVL. The rules of applying KVL. First one, the circuit should be closed. This circuit should be closed. Second, break the current. Break the current. I will explain all these things. Now just write break the current. 3, choose a path. Choose a path. How you will choose your path, that is completely depends on you. How you will choose your path, that is completely depends on you. You can choose a clockwise path or you can choose a anti-clockwise path. It totally depends on you. So what are the conventions here? Let's say this one is a resistor R and current is flowing in this direction. Now for resistor there is no sign of polarity, that means there is no particular positive end or no particular negative end. So let's say here current is flowing in this direction. So we all know current flows from higher potential to lower potential. If that point is P1 and that point is P2, definitely the potential of the point P1 is more than that of potential of point P2, because current flows from higher potential to lower potential. So in this case, if we choose the path in this direction, that means we are moving according to the path is moving from higher potential to lower potential. That means from positive to negative, because in physics we basically use positive sign to represent higher potential and negative to represent lower potential. So here we are moving from higher potential to lower potential. That means we are losing value. Just it's like life. When you move from higher position to lower position, that means you are losing your position, you are dropping something. And when you move from lower position to higher position, that means you are gaining something. That means things are added with your life. And when you are losing, that means things are subtracted from your life. It's like that. So here, let the path is from P1 to P2. So the potential across the resistor will be V equal to minus IR. Remember, if the direction of path and direction of current through the resistor are in the same direction, you have to remember in this way, if the direction of path and the direction of current flowing through the resistor are in the same direction, then potential across the resistor will be IR, but it will be with negative sign because there occurs drop in potential. Now imagine in the same resistor, if the path is in this direction, then the potential across the resistor V will be IR, plus IR. Why? Because here the path is from lower potential to higher potential. That means we are moving from lower position to higher position. That means we are gaining something. That means things are added with us. That is why we will use positive sign. And for battery or cell, in this case, let's say this is a battery of V volt. So here, if the direction of path is this, then the potential will be minus V. Why? Because we are moving from higher potential to lower potential, from positive terminal to negative terminal. So the potential in this case for this path will be minus V volt. Clear? And if the path is in this direction, then the potential will be plus V. Why? Because here we are moving from lower potential to higher potential. That means from negative potential to positive potential. This is the rule that you have to follow. Now we will apply KVL. So let's say this is 2 ohm resistor, this is 3 ohm resistor, and this is a battery having 20 volt. So what will be the current flowing through the circuit? Sir, this is very simple. We can easily calculate R equivalent will be 3 plus 2, 5 ohm, and so current I will be 20 by 5, that means 4 ampere. We can easily calculate it, sir. That will be 4 ampere. Okay, we can easily calculate, but no KVL is there. If we apply KVL, then what it will be? This is 2 ohm, this is 3 ohm, and this is basically 20 volt. Now the circuit should be closed for applying KVL, so it is closed. Now we have to break the current. Let I is the current. Okay, I is the current that emits from the battery. Now let's say the direction of path is this. Here the direction of path is this. You can take it clockwise or you can take it anti-clockwise. It completely depends on you, no matter. So for this path, applying KVL, what it will be. And another thing that you have to remember, to find the potential across the resistor or potential across the cell, it is positive or negative, always you have to take the nearest path. That means for this cell, you have to take the direction of this path, not this one. Okay. For this cell, you have to take this path. For this resistor, you have to take this path. Okay. For this resistor, you have to take this path, which is nearest. Okay. Now for this cell, we are moving from lower potential to higher potential. That means we can take it positive. Plus, here direction of current is this and direction of path is also in the same direction. So we can write here minus 2I, because I current is flowing through it. So potential across it will be IR, 2 into I, but it will be negative. Similarly, here also it will be minus 3I, that will be equal to 0. So the value is 20 minus 5i is equal to 0. So I is equal to 4. No problem. The initial value was 4. By applying KVL, also the value is 4. Now, we will solve it for different direction of path. Let's say this one is 2 ohm, this one is 20 volt, this one is 3 ohm. So now you have to break the currents. So these are the currents. And let's say here the direction of path is this. Just see here, that one is anti-clockwise and that one is clockwise. Just see the result here. Here we are moving for the battery from positive terminal to negative terminal. So it will be minus 20 plus, because the algebraic sum of all the voltages of a closed loop of any network is equal to 0. For that one, direction of current is this, and we are moving in this direction opposite. That means it will be positive 2i plus, here current is flowing in this direction and the path is opposite here. Here also the path is opposite because we are moving from bottom to up and current is flowing from up to down. So here it will also be 3i, that will be equal to 0. So if you apply minus 20 plus 5i is equal to 0. So definitely I is equal to 4 here also. So no problem. If you take the path clockwise or if you take the path anti-clockwise, it will not affect your result. And one thing that you have to remember at the time of solving this type of numerical, just imagine during the exam, you choose a path and find a value of current. After calculation, the value of current, just imagine after calculation, the value of current is minus 4 ampere. So what you will write in the answer? You will write the value of current through this resistor will be 4 ampere. You don't need to take the negative sign. The value of current through this resistor will be 4 ampere and its actual direction will be opposite to that our assumed direction. That you have to write if after calculation the value of current is negative, and if it is positive, no problem. Okay. Now we will solve few more numericals on the basis of this. Let's see this circuit. Here you have to find the value of current flowing through this 10 ohm resistor which is connected between the points A and B. Okay. So how we will solve it? First, this is a closed circuit. How many loops are there? One loop, two loops. So we have to apply KVL twice. And there are two batteries. So what we'll do, sir? You have to break the currents. You have to maintain the rule. So if you want, you can emit the current from this battery, or if you want, you can emit the current from this battery. But from my personal experience, I'll always suggest you that when there will be two batteries, always use the larger one. Here 50 volt is the larger one, so we'll break the currents from this 50 volt. It will be easier to solve the numerical. Okay, if you use this 20 volt, no problem will be there. No problem. Easily you will be able to match the answer, but it's my personal experience. You have to if you use the larger one, it will be easy. So let's say I is the current. I is the current. Now here I also, but here it will break into two parts. I1 and that one is I minus I1. Because I here in this junction, they will break into two parts. So here current is I minus I1. I minus I1 is the current here also. And here I1. So I minus I1 plus I1, they will be added up and the value will be I. So I current emits from the battery and I current also enters to the battery. Now we have to choose path. So how we'll choose path? Let's say here the direction of path is this and this is loop 1. So applying KVL for loop 1. For loop 1, what it will be? For the cell or for the battery, the direction is from negative to positive. So that will be 50. And for that one, direction of current is this and the direction of path is of the nearest one is also this. So you have to take it minus 20I. And now for that one, direction of current is this, path is also this. So we have to take it minus 10I1 equal to 0. After solving it, we can write 5 minus 2I minus I1 is equal to 0. This is equation 1. Let's say this is loop 2. So we will consider the path in this way. Sometimes students ask the question, sir, for both these loops, we have to choose the path in the same way. Just because here this is anti-clockwise, this is also anti-clockwise. No. It doesn't matter. There is no specific rule to choose the loop. You can take it anti-clockwise, and if you want, you can take it clockwise, no matter. There is no rule that for both the loops you have to choose the path in the same way, in the same sense, no matter. It's completely on you. So now for loop 2, see here carefully, for loop 2 what it will be, we are moving for the battery, this is 20-volt battery, from the lower potential to higher potential. So it will be 20, for this resistor current is in this direction, and we have to consider this 10 ohm for both this loop, because this is present in this loop also and in this loop also. So it is current flowing in this direction and the path is opposite, so we have to take it positive, plus 10 I1, but that one is negative for loop 1. That's the beautiness of KVL, that it doesn't mean that for loop 1 it was negative, so loop 2 it will also be negative. No, it depends on the direction of current and the path that you choose. And from this resistor, direction of current is from bottom to up, and direction of path is also from bottom to up, so that will be negative. So minus 10 I minus I1 equal to 0, because I minus I1 is the current flowing through this branch. So 20 plus 10 I1 minus 10 I plus 10 I1 is equal to 0. We can write 20 plus 20 I1 minus 10 I is equal to 0. We can write 2 plus 2 I1 minus I is equal to 0. This is equation 2. Now we have to find the value of I1. So how we will calculate I1? So now 1 minus 2 into 2. 1 minus 2 into equation 2. This is equation 1 minus 2 into equation 2. So equation 1 is 5 minus 2I minus I1. And if you multiply 2 with 2, that will be, and then you have to take the negative sign also, that will be 4 plus 4 I1 minus 2I is equal to 0. So the value will be 5 minus 2I minus I1 minus 4 I1 plus 2I is equal to 0. So this 2I will cancel each other. So the value will be 5 minus 4, 1, and that will be minus 5I1 is equal to 0. So I1 is equal to 1 by 5, that means 0.2 ampere. This is the value of current flowing through this 10 ohm resistor connected between A and B point. That is our question. I hope things are very clear. We will do another numerical on the basis of KVL. See this circuit carefully. Here you have to find the value of current flowing through this 200 ohm resistor. So these are two closed circuits. We can easily apply KVL here, and among these two batteries, this one is larger. So we have to break the current from here. So let's say I is the current. I, after at this junction point, they will break into two parts. Let's say that one is I1 and that one is I minus I1. So that one is also I minus I1 here. That one is I minus I1. At that point, I minus I1 plus I1 will add it, and the value will be I minus I1 plus I1. So I1 and I1 will cancel each other. I will be there. So I is the value. Now we have to choose path. Let's say this is the direction of path here, and this is loop 1. So for loop 1, we can write 30, because this is the direction of path, minus 150I minus 200 I1 equal to 0. So it will be 3 minus 15I minus 20 I1 is equal to 0. This is equation 1. And for loop 2, what it will be? This is loop 2. So let's say this is the direction of path, because we have to choose a path. So for loop 2, that will be 10 plus 100 I minus I1. Why plus? Because direction of current through this 100 ohm resistor is this, and direction of path nearest to this resistor is opposite to that one. And that one will be minus 200 I1 is equal to 0. After solving, that value will be 10 plus 100 I minus 100 I1 minus 200 I1 equal to 0. So the value will be 10 plus 100 I minus 300 I1 equal to 0. We can write 1 plus 10 I minus 30 I1 equal to 0. This is the equation 2. See these two equations carefully. This is equation 1 and this is equation 2. Now by solving these two equations, we have to find the value of I1. So what we can do here, we will multiply equation 1 by 2 and then add this entire thing with equation 2 and multiply the equation 2 with 3. So see this thing carefully. That will be, here we are multiplying the equation 1 by 2. So it will be 6 minus 30i minus 40i1, and then plus we have to multiply equation 2 by 3. So it will be 3 plus 30i, and then it will be minus 90i1 is equal to 0. Now we can write 6 minus 30i minus 40i1 plus 3 plus 30i minus 90i1 equal to 0. 30i will cancel each other. So the value will be 9, and that will be minus 130 I1 equal to 0. So the value will be I1 equal to 9 by 130 ampere. So this is the current flowing through the 200 ohm resistor. I hope things are very clear for all of you. Now we will solve another one. See this circuit, here you have to find the value of current flowing through this 20 ohm resistor. So how we will solve it? These are two loops. We can easily apply KVL here. So among these two battery, 2 volt is the larger one. So we'll break the current from here. So let's say this is I, this is also I. Now it will be I1 here, and here it will be I minus I1. So it will also be, here it will also be I minus I1, and through this one is I1. So this one is I1, and from this branch it will be I minus I1. Here they will add with each other, and here it will be I again. Okay. So we'll apply KVL here. So this is the direction of path, and this is loop 1. So for loop 1, what we can write? What we can write for loop 1? We can write 2, this 2 volt battery, 2 minus 20 I1, because direction of current is this and direction of path is also same, and for that one direction of current is this and direction of path is also same. So we can write minus 0.1 I is equal to 0. You can write this thing. Now for this is equation 1. Let's say for loop 2, what can I do? Let's say this is the direction of path. This is loop 2. So for loop 2, what we can write? We can write for this cell, it will be 1 volt battery positive, and that will be negative, minus 20 I1, and current, direction of current is this, and direction of path, see the direction of path here, direction of current is this and direction of path is this. So they are opposite to each other. So that will be plus 1 into I minus I1 is equal to 0. After solving, we can write here 1 minus 20 I1 plus I minus I1 equal to 0. We can write 1 minus 21 I1 plus I is equal to 0. This is equation 2. Now by solving these two equations, we have to find the value of I1, because I1 is the value of current that is flowing through the 20 ohm resistor. From these two equations, to find the value of I1, I think if we do this step, then we'll be easily remove the value of I, and then we'll got the value of I1. So what we have to do, we have to add the equation 1 with equation 2, but before that we have to multiply the equation 2 with 0.1. So let's write this step. 2 minus 20 I1 minus 0.1 I plus, the step will be, we have to multiply equation 2 by 0.1. So that will be 0.1 minus 21 into 0.1, that will be 2.1 I1, and that term will be plus 0.1 I is equal to 0. After solving that one, 2 minus 20 I1 minus 0.1 I plus 0.1 minus 2.1 I1 plus 0.1 I, that will be equal to 0. So minus 0.1 I and plus 0.1 I, this term will cancel each other. So the value will be 2 plus 0.1 minus 20 I1 plus 2.1 I1 equal to 0. So that value will be 2.1 is equal to 22.1 I1, and the value of I1 will be 2.1 divided by 22.1. So after solving, that value will be 0.095 ampere. So I believe KCL and KVL are completely clear for you, and now you have to solve few numericals. Just open your book and take few numericals and solve them by yourself. Things will be very clear. Okay.